Hey everyone, welcome to the CSI Secret Store community call. Today is March 30th, 2023. This call falls under the CNCF Code of Conduct. And also this is recorded and will be published to YouTube. Please add your name to the attendees list if you already haven't. And then we have 3 items on the agenda. I can help moderate. Does anyone want to volunteer to take notes?
I'll do it.
No. Thanks, Tim. Okay. The first discussion item is the disconnected scenarios, the caching. Xana, do you want to talk about it?
Yeah, I just wanted to set aside some time to see if there was any points of this that we wanted to discuss further on the call, or yeah, I think probably the area that we're zeroing in on is storage of secrets and whether we want to use a CRD or what. I have some options highlighted in the bottom of the doc here. Yeah.
Storage of course. Yeah. Yeah, and I think with the CRD approach, Tommy's comment is still valid. Like, how do we make sure that only the driver on the node has access to it?
Yeah, I think Mo brought up on the last call too that it might be a good idea to take this to an upcoming SIG-Auth meeting and see what they have to say about it.
I was gonna ask, what credential does the driver run as on the cluster?
What do you mean? Run as
Like, does it have an identity on the Kubernetes API?
So it has its own service account just because it has the service create and other operations, but it has no other identity per se. Like it basically just uses the workload entity. Talking to external stores, it has no identity at all. It just delegates it to the providers.
Okay, so there's no identity over the UDS, but when it makes Kubernetes API calls, it's just using a regular service account doing regular Kubernetes stuff.
Mm-hmm.
I think the concern was if you granted the driver access to read its new fancy well, actually, so it should, the driver right now needs to have the ability to create Kubernetes secrets, right? Because they can sync them. So it can do that in all namespaces.
Yes, it is. So we don't install the role by default for syncing as secrets. Like if the user opts into the feature, then they install those required roles. But if they opt in, yes, it can create Kubernetes secret in any namespace.
Can it do anything but create, or is it just create?
It can do anything.
Okay. Uh, so that would mean that a kubelet that's running the daemon set for CSI secret store driver in that mode can read all secrets on the cluster, because it can ask for a service account token for that driver.
Right.
Is that expected? I don't feel like that's expected.
I mean, I think if we go down the route of splitting the controller and having the driver only do the mount, in that scenario, we could reduce the number of secrets that it's allowed access to. So like we could basically, no, actually, even then each driver pod would be able to get any secret that's accessible, right?
Right. So there's no getting out of this situation in terms of the level of access that the service account has. Like, not really. Because we don't have like a reference-based authorizer, like a generic one. Like if we had a generic reference-based authorizer, like the node authorizer, then yeah, we could come up with a strategy for saying that the driver can read or write secrets in namespaces that make sense for the context of the driver running, right? I'm more stepping back for a second and saying that, like, if you use the secret sync feature, you have effectively made it so every kubelet can read every secret on the cluster because it's a daemon set.
Yeah, this is why we made it optional and not like a GA feature yet, I think.
Yeah. I don't feel like that is like expected behavior. Like I would not expect that to happen, that like by using this thing, I like really weaken the security model of the node authorizer and the node admission plugin. Right, because in most environments, like basically the important environments that have gone through upgrades, Kubernetes secrets still contain service account tokens from older installs. Thus, read on secret is effectively cluster admin. Right, so that really kind of nullifies the entire node authorizer and node admission plugin, because you can just let any kubelet escalate if this component is installed. So yeah. So thinking through that. So obviously that means if we build a controller thingy, it's going to have a separate identity, because it has to, like, it cannot use the same service account and probably shouldn't even use the same namespace.
Wait, when you say controller, are you referring to the separate controller for the sync stuff, or
if we build a controller to sync Kubernetes secrets, and that's exactly the only thing it does, it certainly needs a separate identity, but it might also need like a separate namespace and just live in its own spot and do its own thing, like away from any confusion.
I would have to question if like it's worth the time of even doing that with ESO out there. Like ESO kind of already, I don't know, is it worth the engineering effort for us to like rip that out and build a whole new controller just for that, when like that project already exists?
Yeah, so I think the potential value add that CSI Secret Store, or I can't be called CSI Secret Store because it won't have anything to do with CSI, so it's gonna have to be something else. That's gonna be painful. Whatever this controller is called, the potential value add they could have is we could still model its identity in the same way that we model the identity of CSI Secret Store. So when the daemon set is running and it talks to providers and stuff, the identity of the workload is what's used to fetch data from the cloud. That's not true in ESO. When ESO runs with workload identity, it's got one global identity that is the controller. So there's no granularity of access. It's, well, if there is granularity of access, it has to be provided by ESO. So it basically nullifies all the fancy auth-z policies you have in your cloud, and instead says, no, you got to make ESO do all of those, whatever. I don't know if it does or does not do those things.
Yeah, I think one is that, and then the second one is also like users who are already accustomed to our like custom resources and stuff, like they don't have to go do any kind of migration. Like the goal would be that they still use the same secret provider class. And then also all the providers that we have don't have to go make any code changes. Like we could take those and then just run it with this new controller, and then it would just work. Like, so in terms of the user migration, there's no story required.
Well, like I guess to that specific thought train, if someone is currently using secret CI store to do both CSI stuff and Kubernetes secret stuff, do we feel like if we split stuff up, we could keep everything working with no breaking changes?
Yeah, because it's, at least from the CRD perspective, it's two different fields. There's a field called secret objects, which is what you define to explicitly say, I want to sync as a Kubernetes secret. And then you define like a template to say what your secret would look like, and then which data from your external secret store is your value here, right? So if we split it into two separate things, if they use the exact same CRD, it would just work in both of it. So like only the CSI driver will look at what is required for the mount part, and then it'll return those files. And for the controller, the provider would still return those files. It's just the controller will also understand the schema of the secret objects that's defined and do the sync.
Okay, so based on that, we could actually do like one of the questions I had for y'all was like, would there be breaking changes if we went down this route that like required us to like, I don't know, do like a V2 of the stuff as a way of like saying that no, like we're gonna break some stuff. So like if you don't want to break stuff, stay at V1 until you're ready to migrate. But I didn't know if we could get the changes we wanted without making some kind of breaking change.
Yeah, I think we can do it without a breaking change. Like I think when I wrote the proposal initially, also that was the reason, right? Like it's from user perspective, it's more like installing this separate component. The behavior is slightly different because obviously like today the sync secret only happens when you go create a pod and things like that. But going forward, obviously it's just like you create the custom resource and it automatically goes and creates it for you. So like those changes in behavior, I think if we call those as like change in behavior, we might have to like say now CSI driver 2.0 will only do this mount. And if you still want sync, just go install the separate controller. But if you need time to do like two separate things, just keep going with the 1.0 version.
Okay, so I think what we were saying is there's no breaking change of users of the Kubernetes REST API that we provide via the custom resources. But from the perspective of like an admin or a deployer, if they were to just blindly apply manifests, you would get a change in behavior and possibly like a breakage in functionality because you didn't realize you were supposed to deploy the controller because it didn't used to exist. Yeah, I don't know if that counts as truly breaking. I mean, certainly there would need to be like some big warning on the release note saying that, hey, like you got to deploy this other thing and run it. And also now you no longer need to create pods. It just happens, which people might say is a bug fix, not a bad thing. Okay. Yeah, I mean, that seems fine. What have y'all traditionally done in the past? Would you just do like a minor, like a Kubernetes style minor version bump just to say that like, you know, it's 1.n, or would you feel like something like this would warrant a full 2.0?
I think this change in behavior might warrant a 2.0. Like, so the driver would become 2.0, but the controller would start off at some point, or if we want to like keep it thing, we can see. But I think the driver would require a 2.0 just because of the change in functionality and like it's a whole separate component. Like with minor releases, I think we've deprecated flags and all of those, right? But that also we try and follow like the Kubernetes process of deprecating over 3 releases. So like the first release, we say it's deprecated, and then like we remove it in the n-2 release saying like now you cannot configure it, and then that finally goes away.
Okay. So I assume because the project is at a V1 release, there's never been a time where there was like 2 releases sort of like that are semi-active.
So we support n-1 releases, so 2 minor releases basically. So right now we support 1.3 and 1.2 of the driver.
So let's say there was like a CVE. Would you patch both the 1.2 and the 1.3 release?
We try to, yes.
Okay. Well, then it's fine. Then you guys already done the. Yeah. So okay. So then you could say that you're gonna patch the 2.0 and the 1.3 releases.
Right. Like I think we need to keep the 1 dot just for a while if users are like already there and they don't want to migrate immediately. But
Right.
like whenever 2.1 hits, that is when we say like, hey, now you're going to be running an unsupported thing. So like you have to migrate to this new format.
Right. Okay. So on the topic of like you using custom resources that are like encrypted versus like Kubernetes secrets, I think last time when I talked with you, Xander, I had thrown out the idea that would it be the end of the world if the future controller, when it needed to do its caching, if it just wrote the secrets from the provider into its namespace as a Kubernetes secret? Basically, do we need the indirection between the custom resource and the Kubernetes secret?
Wait, can you expand more on that? Like,
so the idea of making this cache secret object is to effectively make like a secret class that has a different authorization policy for reads and writes to it. Right. So, and what that's trying to protect against is if you're running something like Nginx ingress on your cluster and it has full read on all secrets, because that's how it fetches the secrets for its ingress objects, right? And what you're saying is, I want to have this separation, and I'm going to make this custom resource to have that separation. So not only would you need to be able to read Kubernetes secrets to get the encryption key, you would also have to be able to read the cache secret custom resource. You need both access rights, right? And the assumption there would be is the only actors in the environment that have both is either the cluster admin or the driver or the controller, whatever, right? To somewhat play devil's advocate, I was asking if that is something that the driver controller thing should try to defend against, or like as a for example, I don't know of any other project that does this.
So the first thing is, if the driver controller split happens, this behavior is something we only need to worry about in the driver, right? Because the controller does not even need any of this anymore. Like the controller syncs his Kubernetes secret. So the controller syncs his Kubernetes secret, and then that's it. Like that secret stays forever. So it would just work in a disconnected scenario.
Well, no, then you can't honor the cache policy.
So when you sync his Kubernetes secret, there is no real cache policy, right? So like they create the custom resource and they say, just create a Kubernetes secret for me. And how I use that, I will do it on my own.
Right. So okay. So let me back up. That behavior, I think, is incorrect. I would expect that you do sync as Kubernetes secrets, but you have to tell us for how long. And when the cache expires, we go delete your secret.
Yeah, I think we're talking about 2 different things there. We're talking about like the extraction of the sync controller and the caching, which are like, yeah.
Like sorry. So like I'm thinking about how does the offline feature interact with Kubernetes secrets? I don't think we want to go the ESO route of once we give you the secret, it's yours,
Right.
and you do whatever you want. Right. I think we have to be stricter than that. Like, I don't care if someone sets their cache policy to 10 years, whatever. I don't care. That's on you. But it should not have no capability of revoking access.
So essentially, it won't even be a cache policy, right? It would just be like something synonymous to like an ephemeral secret. So basically, they tell us create a Kubernetes secret for me, but also this secret has like an expiry. So like after this particular time, you just delete the secret.
Yeah, I mean, yeah, you could say it that way. But yeah, that's where I was sort of getting at the right. Okay. Yeah. So I guess, yeah, there's two very similar related problems. There is the driver that needs to work in offline mode, and then there's the controller that also needs to work in offline mode. Right. And do they use the same strategy for doing that? By the way, I could see a user being very confused if the driver is able to, in offline mode, mount a secret because it saw it, but for whatever reason, the controller didn't see it and it can't create the same secret. That seems weird and unexpected. I'm not sure if there's a fix to that because they're just separate components and they have their own like logic. I could see that being confusing. But yeah, so there, like, so the thing I was thinking about is like to me, the controller also needs to have a place where it puts its secrets for itself, because in my head, many different actors might want access to the same secret. Right. So it has to have like the authoritative copy of the secret, and then just the childs that are just replaced with whatever the contents of that are. Does that make sense?
So we're talking about the caching in the controller, right?
Yeah. Right. I feel like if we build offline mode, it needs to work for both components. It can't just work for one of them.
Right. Should we discuss the driver one first? Like how it would work, and then we can think for the controller one too.
Yeah, we can back up. So for the driver one, I was that's sort of Xander's proposal, right? Is like what are the set of choices we have here, right? So like I had thrown out the question of, do we need this cache secret CRD?
I think I guess I don't know enough about like the security posture of Kubernetes secrets. I think everyone else on this call probably has more of an opinion on usage of Kubernetes secrets than me. So I don't know really like what if it's a huge problem to just do this with Kubernetes secrets, and like I suppose you could still encrypt the values with a local key, right?
But where do you put the local key?
Yeah.
That's sort of the annoying thing, right? There's no concept of like an HSM or something inside Kubernetes that you could access and like somehow better protect the secrets. It's just a flat authorization model.
Yeah.
Yeah, that key would, I mean, at least from the proposal, it stays in the Kubernetes secret. But that also just means any instance of the driver pod could access it. And I think the thing with the cache secret is all the driver pods can access it. So like basically access goes out of the node, like unlike today.
So we're saying that ignoring the syncing of secrets features, let's say pretend that wasn't even there. If you add this offline mode capability to the driver, now because the driver is running on every kubelet, and the driver would need access to its own namespace as secrets. That means now, I guess every kubelet already had access to those secrets because it has to do the file mounts for you, but now it like really has access to them because you're sticking them in etcd in Kubernetes secrets. So like you made it extra easy for it to find them. Like it doesn't even have to mess around with file system stuff. And as you mentioned though, whereas previously each kubelet would have its own like file system that it could mess with, now each kubelet would be able to read all of the secrets that have been synced in. Because each kubelet can run as the daemon set user and thus read the secrets. None of this sounds great, by the way. All of this sounds like further and further weakening of the boundaries.
Okay.
And then what were you saying, Anish, about the so that's the weakening from the kubelet side. What was the weakening from the driver side?
No, I think the kubelet one is the main one. Like, I mean, from the driver side, like, I think it still comes down to what we use. If we go down this route, what we use as the cache key. Like, if it's the service account and all of that, even if all the drivers can read this one cached object, because it's bound to the service account, it's just going to give it to the pod that has access to the service account. So, like, I don't think it's going to be weakening or anything. But the kubelet part was the main one.
Right. Okay. So it weakens the kubelet part, but it also weakens the driver part in the sense that now all instances of the driver have access to all secrets, whereas previously individual instances of the driver only had access to the secrets that they had already gone through the process of getting from their provider.
I mean, yeah, like today we have no kind of caching. So like it's almost always like they have no actual access, right? They basically just call out, get it at the time the pod is created. But if they did go and look into the file system, yeah, they had access to those secrets for that pod. But I think like in terms of auth, it comes down to service account eventually, right? Like if the same pod is running on every single node, like every instance of the driver already had access to it. And if we use the cache key for only this particular service account, even though all the driver pods have access to it, if they are the good actors, then they would only mount it for the pods that have that service account. Like if there's some kind of serious bug, yes, then basically the driver would just give access to all the secrets. Like it would mount the wrong secrets in the wrong pods and give them access to it.
Right. So I guess, do we feel comfortable saying that by building offline support into the driver, which obviously will still be opt-in if you want it, we are comfortable with both the weakening on the driver side, which you could argue is fine. Like the driver is supposed to be a trusted agent for fetching secrets, so whatever. But are we fine with the weakening on the kubelet side, where we just say, yeah, now every kubelet in your environment can read all of the secrets from your cloud that you can fetch or have fetched at least?
The alternative, right, is the volume option, which then brings us into the realm of like storage orchestration. Yeah.
Right. With the volume option, because we would not be using a Kubernetes REST API, we would not give access to the driver to put them where the kubelet can kind of get to them, like all kubelets, all instances of all kubelets. It would instead be local. Though I suppose you could argue though, if whatever, like say we did it based on volumes, those volumes are accessible by kubelets, and since we're running on everything, we would sync the volume somehow magically. Raft magic would happen, and we would sync it across. But then every kubelet would then have access to it anyway, right?
Yeah.
Let's just get rid of the kubelet. Who needs it? Doesn't even do anything.
Yeah. So this might just be a side effect, right? Like an inherent side effect of how this has to work. Right? It's like a mixture of you want offline support and you're using a daemon set. Like when you intersect those together, it just basically grants the read on those objects to the kubelets.
I mean, the attack surface on these clusters is theoretically already smaller by the nature of them being disconnected.
You can't get to my cluster. Unplug it.
I mean, I think if we take the approach of saying during the time of disconnection, you're vulnerable, but once you come back online, we will switch back to the default behavior and like not have all these things. That could be fine. Like basically, like we don't rely on the cache and any of that once we are online. So that is the ability for us to distinguish between the offline mode and like actual errors, right? Like at which point do we want to look at the cache and use that value, or we are online and there's an actual error. Like in those cases, we just want the error out, like straight up, like how we do it today. So I think we need that ability to distinguish. So like the provider could tell us, hey, use the cache or not. And so that means when we come out of the offline mode, then we can still go back to the old behavior. So we're still as secure as we are today.
The driver is as secure, but the kubelet model isn't as secure, right?
Oh, yeah.
Right. Yeah, so yeah, no, I totally agree with the driver uses the cache when it strongly understands that it should use the cache. It should not just use the cache because it has it. Right. Like as a, for example, if it gets like a 401 unauthorized or something from the provider, it should not fall back to the cache and just ignore that and be like, no, you didn't really mean that, right? I already cached. That's not what it should do.
But also when you say the kubelet one still exists, that you're referring to like kubelet having access to all the mounts, right? So basically it has access to the file system.
No, what I was saying is that like when we come online, right, we're not going to go delete our cache. Or we can't do that because then the next time we go offline, we won't have cache, right? So
but
that
we have to honor the TTL.
Say again?
Plus we have to honor the TTL that the user said.
Right. We had, yeah. So we should obviously go delete the cache when the TTL expires as a way of like preventing us from accidentally ever using the cache when it's been expired. But yeah, I think you foundationally sort of give all kubelets where your daemon set is running access to all of the secrets that you're going to sync. I think you have to accept that. I think that's just part of how this has to work. I don't think there's any way of getting around that.
Yeah.
Though it does, to me, make it sound very clearly that you must opt into this feature. You just can't just do it for free because it does weaken things in ways that are not obvious.
Yeah.
Tommy, you're quiet. Did you have any thoughts?
No. I think this accurately covers the issues. I think like I think there may be many customers that don't care about the kubelet or like aren't like that are treating just their cluster as all the same kubelet like identities anyway. So like that's where I think it's important to opt in the future. And I'm not sure, yeah, how much to weigh that, like weigh solving that versus solving like more immediate user things of like, yeah, wanting it in secrets and wanting it cached. Yeah, I don't know. It seems hard.
Okay, so if we don't see any security value of doing like the volume-based approach, because I think it comes out in the wash as being the same security semantics, is the only open question on the cache secret thing is, do we use the indirection with the custom resource versus just using a cube secret? Or is there other open questions in people's minds specific to this design?
So when you say the indirection, are you referring to the Kubernetes secret and the CRD, the custom resource?
Right. Right. Like if you decided that you didn't care about that, you could just put everything in Kubernetes secrets, right? And that is your cache.
I mean, yeah, I mean, if it's all in, if we're doing all of this in kube system, right? Like, let's say like we're caching it and putting in kube system, like as a cluster admin, I can control access on who has access to which namespaces, secrets in which namespace. So like a user wouldn't have access to the kube system. But if you have it as a custom resource, then you could basically say no one has access to that custom resource, like in any namespace. So like, I think it gives you that one small edge, because you can control the RBAC on the entire group.
Right. Yeah, that's why I kind of think of this a secret class, right? Like it's just it is a secret, it just has a separate authorization check to get access to the data inside of it. I mean, if we want, maybe we just bring this to the next SIGAuth meeting and be like, does this make sense? Or are we just making up like a concept just because we think we should? Xander, did you have other open questions? I feel like there was like a list at the bottom and now I can't remember what's in it.
I think there was like some open questions down there, but I think those are all probably more semantic. Like I think the core of it was like the storage question, like how we actually cache the secrets.
Yeah, I think this one, we answered it with the whole custom resource, right? So like, I'm gonna do that. This one is still open. So like, I think this is what we need to like come up with.
So what work is needed there? Is this something that we would have to go like make a small POC or something to kind of play around with the code to get a sense of like how?
Yeah.
I can't like immediately conceptualize what the cache key is going to be other than like hand waving like workload and something. Also, that reminds me, when you do the CSI volume mount, you can ask for like multiple tokens, right?
Yes, you can. So if you define different audiences, you get a token for each audience.
Do we send all of those tokens to the provider?
Yeah, because we don't know which one the provider wants. So like we basically send the entire thing and then the provider decides which one it wants to use.
Oh, sorry, cache key has to take into account like you have 7 service accounts. Any one of those 7 is, or actually no, would
one service account, but different audience tokens.
Right, different audiences, right? So I guess as a gut check, would the cache key just be that service account, or would the cache key be all of the audiences?
It has to be for the specific audience, right? So like we would have to rely on the provider to tell us which audience it used out of the 7 or like audiences that it used. To cache based on that, because the next time some other pod comes with just one of the audience, we don't want to give it access to that.
I think part of that was my initial, like one of the reasons when I was originally thinking of storing the CRD in the workloads namespace and the cache key in kube system, because then you can rely on like what's defined in the secret provider class to kind of, since it's namespace scoped, that kind of gives you some information on the key, but I don't know if that's actually a good idea or not.
I don't know. I mean, so certainly we're saying nothing but cluster admin and our driver stuff is going to have access to this custom resource. and it's gonna be encrypted. So like even if you did have access to it, you still couldn't read it because it'd be noise. Okay, so but based on what you just said, Anish, to me, it opens the question that I wasn't sure about, which is, can we do this purely at the driver, or does this actually definitely require provider level changes? I was hoping that it could be in the driver, but it doesn't sound like it.
I think it may require provider changes just in the sense of like, if the provider reaches out to try and get a secret and doesn't have connectivity, it knows how to respond in such a way that the driver knows what to do then. Right? Or am I just making that problem up?
I have no idea what kind of error the driver gets when the provider goes offline, and if it's like something that the driver can explicitly make sense of, like, oh, it's a network error, and thus I do fall back to cache. That one I could think we might be able to do without provider changes, but I'm less sure about like if the provider wants to inform us about some logic that we need to do, like, for example, the whole audience thing. There's no way for us to infer that. It's a black box, right? But it does sound really kind of terrible if we have like 7 providers that exist today. We gotta go tell all of them, hey, if you want to support caching, now you gotta like return extra data to us so that we know how to do the caching. I mean, maybe it's fine, but it seems a little not great.
I think on the provider level, already there are few required changes because like provider has to tell us how long it has to cache and all of those. Because the provider is the one that tells us, right? And then also I think today we talked about we need to know what error means, which error means we could use the cache value. So like that is also something that the provider has to tell us. Like as part of the failure, it can say like use cache, true or false. So it makes a decision. So like those kind of changes are still required.
Okay.
On a minimal level for them to support it.
So would we, what was I going to ask? So I don't know like what kind of errors come over that RPC. So are you saying that like we can't tell from the gRPC code that it was like a network failure?
For network failures to the provider, I mean, we can, if the RPC calls fails, then that's there, but we can't tell what error the provider had while talking to the external secret store. Like the provider passes it, but we just have to see if that is consistent across all the providers, right? Like in terms of what error, like, I mean, I think unauthorized and stuff like that, like would be similar across all the providers. But if there's something else or like the network failure, like I think we have to see how the error looks like for different providers. And if we don't want the driver to try and understand that error, instead we want the provider to explicitly tell us this is an error that you can use the cache.
Yeah, I don't think we want implicit the things that make us do security actions. That's generally a surefire way to do something wrong. So Xander, correct me if I'm wrong. I thought the caching policy was defined at the custom resource level and not the provider level. I don't have an opinion really here. I'm mostly just asking right now.
I think in the proposal here, I have it defined at the secret provider class level. Yeah.
So this is at the driver level.
Yeah, and so that's, I think that actually maybe was one of the open questions, whether it would be defined at the provider class level or at the individual secret level.
I mean,
Yeah.
certainly be more flexible if the provider can just say every single time that you call it that this is the.
Can use the secret object parameters for that. I mean, they're anyways not strict, right? Provider just has to interpret that.
I don't understand what you just said. Could you read? Could you restate it?
Hang on, I'm trying to grab an example. I mean, when we specify which secrets we want from the provider, that structure is not like the fixed set of structure, right? So we can just provide the TTL there if we want to do it per secret level. That makes sense.
Yeah,
Oh, are you-
I think in terms of caching, we want to cache on the entire secret provider class, right? Like we don't need granularity on the secret level. But I think that it boils down to if we want the provider to tell us the cache key and everything, like do we want the provider to tell us the TTL too? Or that
The-
is
the main concern I have with the provider telling us is like thinking about like the AKV provider, we would then have to come up with some way for users to configure that at that provider level.
Yeah.
So maybe it's a flag or something, but I can't imagine us coming up with some way for them to say this secret is super important, so give it like a 1 hour TTL, but the other one's not so important, so it can be a month. Right? Like I don't know how we would go about doing that because we would have to build an entire config layer there then.
Yeah.
I don't know if that really, I mean, like, yeah, if you really want it, then sure, it makes sense to do that. I guess maybe the way I would think about this is nothing prevents us from doing provider level per secret things in the future, right? Because if we added a new field, the driver would say, oh, I see that the provider told me for this secret, this is the cache. So I ignore the global cache count and I just use this, right?
Yeah.
So I think
That's kind of the approach that we've taken today too. Like for rotation and stuff, like we configure at the driver level, and then we opened an issue asking users if they want to like be granular and do it at each secret provider class, but no one asked for it. So like we ended up just keeping the global one.
okay. Yeah, that seems fine.
Yeah. But I think going back to your point about like in terms of what we want to do next, right? Like I think a POC might definitely help like answer some of these questions for us. Like we could start with building something that uses the service account name and keys and like slowly build on top of that, like for the different scenarios. And then I think we can bring that back to the doc. And then once we have enough implementation details, I think we can take it to Sigath to talk about.
So for SIGAUT, we have the indirection question about the custom resource. And then once we understand enough with the POC to understand the cache key, then we would bring that there and be like, hey, like, here's the high level idea. It's going to be opt-in. The reason it's opt-in is because it weakens the kubelet boundary. Maybe nobody cares. Or if anyone wants this feature, they cannot have that boundary. They have to give up the boundary because the thing is a daemon set. There's no way getting around that. Or you could schedule the daemon set only on the kubelets that you want to be in your pool, but there's nothing further that you can restrict. And then like this is how we're gonna have the providers and drivers cache things, or this is how the caching will work based on the changes to the provider and the driver. Did we break anything basically? Okay. I assume we don't necessarily care if someone sets the TTL to like a really big number. Like if you want to survive an arbitrarily long outage, I don't know, seems fine to me.
Yeah, I think that should be fine. But also the thing to remember is the provider is the one that still tells us if we can use a cache. So
Right.
It still knows if it's not a network error, like we would still not use the cache. So like users will still just not benefit. But if they don't want to remember and go and update the TTL every time, so they just set it to like an arbitrary long value, they can. They're like, I want to survive this failure this week and then probably another failure like 4 weeks from now. So I'm going to set the TTL to 1 year.
Yeah, I mean, I suspect that there's probably like 4 values. One is not on. I don't want anything. One is like something like 72 hours. One might be something like on the order of a week, and then the rest is basically infinite. Right? It's like there's no real mechanical reasons for like most of the intermediates there, right? Because
yeah,
and maybe the 1 week and the year are basically the same thing, which is just cache forever because I don't want to have an outage. But I do want you to honor policy changes as soon as you sort of come back online.
I have question there. So let's say, I mean, we are like disconnected and we have a copy of secret on a pod. Then we came back online, but then we realized the secret might have been updated in the keyboard, right? Then who and what do we do and who will do to update that copy in the driver? Like, do we do our regular periodic sync and say that, hey, now it's changed, so we're going and updating the mount in the driver, I mean in the pod? And what if it has it's also synced as an environment variable in the current state? Like, do we also restart the pod, or how do we make sure that updated copy is updated in the workload after coming back online?
I mean, that behavior does not change today, right? Like if you configure rotation, if you enable rotation, that's exactly what's going to happen. So like periodically you call, if you cannot make the call, you just fail, but you don't do anything. But when your call goes through, you go and update everything.
Right, but it still depends on then the rotation period though. Like today, like people have that same thing, right? That they have to wait till the next rotation cycle hits.
Right.
Okay.
Yeah.
I was curious if you want to do like explicit restart or explicit mount and just, I don't know, like run the rotation cycle or like the updation cycle right after we came back online. Like, do we want to do that or we just leave that?
But how do
regular
you came
rotation?
back online?
Sorry?
But how do you know you came back online?
Yeah, that's true. Sorry, Mo, you were saying something. I'm still thinking.
Yeah, so like I think that's a good point. I'm not 100% sure what we could do there. It does, but it is interesting that if, like, I guess, do you guys have a sense for what people set rotation intervals to normally?
So the default we have is 2 minutes. Some of them who use the driver only for like certificates set it for like 24 hours because they know the certs don't change that often. But I think for people who constantly keep changing, like in DevOps scenario and stuff like that, they even try to keep it at 10 seconds.
10 seconds, good grief. Are you trying to like break the vault?
They want to keep updating their Kubernetes secret like every time they go change a value. So like their entire pipeline deploys and stuff. So like they keep changing it.
Yeah, I've seen folks that they want to aggressively set the interval just so that they don't want to be delayed by the interval, basically. So they want updated secrets as soon as possible, but we have to tell them the other limitation of keyword.
Yeah, but these providers don't support watch, right? So like,
correct, exactly.
Like,
it's polling still, and
yeah, but polling is expensive, right? Like it's not a free thing.
Correct, and that's why I asked that earlier question. Like, people don't want stealth secrets apparently. So right now that they are doing is the like the intense polling, I guess. So that thought is still there, I guess. So how is there a way we can address that in a disconnected as well, or it's just gonna be there too?
Yeah, so I guess in disconnected, when you go offline, the cache policy would take place, and so we would leave everything as is. So today, I would assume that if you get a failure during the rotation interval, you don't do anything. Like, I mean, you might make a log or whatever, or make an event, but you don't do anything to running pods.
No.
Right. So there's a little bit of nuance there, right? Because when you introduce this cache policy with a TTL, does it apply to running pods?
I mean, even if it applies to running pods, nothing changes. Because
you could overwrite the secret with 0, right? You could just put the null byte and say it's expired. You can't have it anymore.
Oh, you're saying during the disconnected period if our TTL expires.
Right.
Yeah, I don't think we would change the behavior. we would still, this is still considered just like a failure, right? Like, so first call is the external secret store, that fails. Then we look at our internal secret store, which is the cache. And if that also fails, we don't go affect any existing workloads. But any new workload that comes up will straight up fail, saying, I don't have anything that I can mount with.
Yeah, I mean, I'm more trying to think about like what is expected behavior here, right? So it's a little weird that new pods can't come up, but the existing pods are coasting on some like old state. But I guess that wouldn't happen, right? Because, well, no matter. So the cache could have expired and thus been invalidated. So even though technically the driver has access, assuming it didn't literally go delete its cache, it's not going to let new pods come up, but it's going to leave the old pods alone.
I mean, think about it. The driver is only really called during like two hooks, right? Like one hook is when the pod gets created, like kubelet tells us to mount. And then the second hook is kubelet explicitly tells us, hey, you go on mount. So in between that mount and unmount, the assumption is the CSI driver is not doing anything there. They added the requires republish in CSI like few releases back where they're like kubelet will call you like periodically. So you go and do whatever you have to, like if the mount had failed before, go retry it, or make sure that it's back to the same state we expect it to be in, kind of things like that, right? But other than that, the expectation is in between that, like you don't go and do anything to the already existing thing unless you're explicitly told to do so.
So let me ask a question. What was the field called? Requires what?
Republish.
Yeah, so that republish field, like, so say that's set and the kubelet does call us and our cache is expired. What do we do?
Nothing.
Right, so we purposely ignore the fact that the user configured a cache TTL and it's no longer going to be honored for this pod because it was running before then.
Yeah, I mean, I think it depends on how we see the cache as. Like, if we see the cache as just something for like future use and stuff like that, like that is a different thing. But if we say like that is the current state of world and like we will use that like strictly, then yeah, you would want to go and break all the existing pods. But in my opinion, it's the first one. Like, you want to care about new pods coming in, but any workload that's already running, you don't want to go touch it.
Yeah, I mean, I think that makes sense. I think what this would come down to is the documentation for the TTL field would very explicitly say that this applies to new pods, that existing pods might not get updates to the secrets if things are offline, but we don't, like, basically once you give access to a Kubernetes to a secret to a running workload, until that workload terminates, it's not going to lose access to that secret.
Yeah. Yeah, and I think like one of the questions that like I saw in some other doc, not this one, is someone had asked, what happens if the cache expires? Like, I think that's a valid question. So like this behavior thing is one, but also like I think in that some other doc I'd seen someone had mentioned that maybe just keep reusing the cache even if it's expired and all of that. Like, I don't think we want to offer that level of granularity where we say what to do if cache expires and stuff. Like, I think instead our document would just tell the users like set an appropriate cache TTL that you think is good enough, rather than policies on what to do with an expired cache and not do and stuff.
Yeah, so we would say if the cache is expired, new stuff doesn't work, but old stuff is unaffected. And if that's a problem for you, well, you set a longer cache TTL, right? And you can set it as long as you want, and thus you can set it long enough that there effectively cannot be an impact on workloads as long as the secret was at least fetched once somewhere. Okay.
Yeah, I think we passed.
We like overtime.
Yeah.
Sorry.
Okay. But this is a good discussion. I think there's the other topic was going to be the controller stuff, like where we wanted to go in detail, but I'll move that to the next agenda. But I think, yeah, we don't have to wait till the next one. Like we can do async conversations too on the design doc. So we can do that on Slack.
Okay. We also probably should find a victim for the POC.
I mean, if you call it victim.
It's just me being fun. That's just me describing it funny ways, not necessarily that it's a bad thing. Might be a fun exercise. I might volunteer to be the victim, mostly because I haven't read the CSI secret store code base in like 3 years or something. So what it does no longer has any context in my head.
Yeah, I can pair with you on it.
Sure. Anything else? Since we're way over time.
I was on mute. I'll see y'all later.
Cool.
Well,
Bye bye.
Yeah.
Yeah.